Welcome to LabMinutes.com and our lab video series on IPv6 on Cisco router. You can find a complete list of IPv6 video on our website by clicking on the link above and sign up for our newsletters to receive the latest video updates. In this video, we will look at how we can interface IPv6 to IPv4 network using NAT-PT. Although NAT-PT is considered obsolete and to be replaced with NAT-64, but as of today, NAT-64 is only supported on higher-end routers like ASR or CRS, and unless you own one of those routers, you're stuck with NAT-PT for now. Although ASA version 901 now supports NAT-64, so that could be another alternative, and we will specifically look at NAT-64 on ASA in a separate video. We're going to start off by looking at static NAT for v4 to v6 and v6 to v4, and then dynamic NAT and PAT for v6 to v4. And then we'll look at how DNS application level gateway will help when you need to do DNS resolution across IPv6 and v4 boundary. And then we're trying to automate the v4 to v6 translation using IPv4 Mapped NAT features. And finally, we will look at how to adjust the NAT global timeout. Now for our lab topology, we have three routers, R1, R2, and R3. Now on the left-hand side of R1, we have IPv6 network with R1 and R3 connected over VLAN 123. And on the right-hand side of R1, we have IPv4 network with R1 and R2 connected over VLAN 12. And we also have a Windows 2008 DNS server at the IP of .32. On R3, we have three loopback 1 through 3 that we will be using as our IPv6 network. And on R2, we have loopback 01 that we'll be using to simulate our IPv4 network. We also have our R1 inside and outside interfaces spanned to a Wireshark machine so we can see what the packet looks like as it gets translated and crosses R1. On the top, we have a list of translation that we will be performing in this lab. And we will come back and revisit each of these translations once we get to the corresponding task. So let's start our configuration with task number 1, NAT-PT. So we need to configure static NAT on R1 and any necessary static routes to allow R3 loopback 1 to communicate with R2 loopback 1 and the DNS server, such that R3 loopback 1 appears as 3303 to R2, and DNS server appears 2001.21 to R3, and R2 loopback 1 appears 2001.22 to R3. And this is corresponding to this static translation right here for the source IPv6 to v4, and then here we have the v4 to v6. Okay, let's bring up our console to R1. First, let's make sure R1 can ping both R3 and R2. So in R1, let's do ping for R3 2001.00 over VLAN 123.3. See, that's pingable, and then to ping R2 is 172.16.12.2. You can see R1 can ping both R2 and R3 at this time. To start our configuration, we're going to take care of R3 first, and all we need at this point is a static route since R3 needs to know how to get to R2. So let's configure a simple default static route. That's going to be IPv6. So config T, IPv6 route, default route pointing to R1, which is 2001.00123.1. Okay, and let's also, while we're on R3, enable debug IPv6 ICMP just to get ready. Okay, let's hop on to R2. R2 also needs to know how to get back to the translated IP, which in this case is 33033, but you can see just to look forward here, most of our IP that we're dealing with for the translated IP is going to be 3.3. something. Then we can, of course, configure a default route from R2 pointing back to R1. But let's be a little bit more specific. So instead of doing a default route pointing back to R1, we're going to do 3.300/16. And that's pointing towards R1 outside interface. Same thing here. Let's debug IP ICMP just to be ready. Now with the configuration on R1, first we're going to take care of IPv6 to v4 translation for our R3 loopback 1. And see if we can move this down a little bit right here. Okay, so config T, the command is IPv6 NAT. If you do question mark, you have an option to go v4 v6 or v6 v4. First we're going to do v6 to v4. Source, since we do a static 1-to-1 NAT, and the source IP for IPv6 is 2001.3003, which is going to get mapped to 33033. Okay, so that's for our source translation. Now for our destination, we're going to do IPv6 NAT but this time instead of v6 v4 it will be v4 v6. Source is 172.16.12.32. Let's take care of that's the IP of our DNS server first. Mapped to 2001.2.1. Okay, and let me just do up arrow here. Instead of 12.32, we want to do 02, which is our second translation, v4 to v6, and that gets mapped to 2001.2.2. Okay, now for the translation to happen, the destination IP needs to match a prefix list, and the command to define that prefix list or prefix is IPv6 NAT to question mark. Here we have an option for a prefix. And this command pretty much dictates which packets with the correct destination IPs will get translated. So for us, we want the destination IP to match 2001.2, and just to make it simple, /96. As you can see here, our v4 to v6 translation is mapped to an IP that starts with 2001.2. Enter. And to enable NAT v6 on the router 1, we get under the interface fast01, which is the inside, or outside rather, and that would be IPv6 NAT to enable, and then we have to do the same thing with the other interface with IPv6 NAT. Okay, now let's take care of a routing on R1. So R1 needs to know how to get to the R3 loopback interfaces as well as R2 loopback interfaces. So R1 needs to IPv6 route to 2001.3, and let's just do /64, and that should include all of the R3 loopback 1, 2, and 3 subnet pointing to R3. Okay, and then for the R2 loopback, so we do IP route 172.16.02, just be a little specific on the IP. And that points to the R2 LAN interface. Just name it as well, and that's R2 loopback 0. And then do IP route 1121 255 172.16.12.2, and this time we name it R2 loopback 1, although we're not really dealing with R2 loopback 1 in this task, but let's go ahead and create a route for that for our future task. Enter. And then we can run debug IPv6 NAT just to get ready. Okay, now if we go to R3, everything should be in place right now. If you're trying to ping 2001, let's say 2, that would be R2 loopback 0. So ping that and source from loopback 1. Just kind of let it run a little bit. And I'm not sure it's very easy to see, but you can see the ping is kind of in the minute. You can see a little dot right here. So it skips every other ping. And if you jump over to R1, you can see the translation here as well. This is the outside in, and then, this is inside out and then outside in translation. And then we also have the inside out, but we never see an outside in. So you can see the ping is only a successful every other ping. And this is because there's a known caveat with the NAT-PT with the router, in that you need to disable Ceph on the router. You can either do it globally, or you can do it based on the interface. Here we're going to do that on the fast01 interface. And the command to disable Ceph is no IP route cache Ceph. And now if we go back to router 3 and we try our ping, you can see we have a 5 successful ping in a row now that we have disabled Ceph forwarding on R1 outside interface. So that's just something that you have to keep in mind when you deal with NAT-PT in the router. And now that we have successful ping, let me bring up Wireshark just to run some packet capture and see what it looks like as it gets translated. So here we have Wireshark, and we're going to start a capture on this interface. Start, and let's go ahead trying to ping one more time. You can see right here we got a bunch of ICMP. So let me stop Wireshark. And I want to show on the R2, you can see with our ICMP debug, or debug ICMP turned on, you can see the R2 is seeing the packet is coming from 330.33, which is the IP we configured to have the R3 loopback 1 translated to. And now if we take a look at our Wireshark capture, you can see the first packet is coming from R3 loopback 1 IPs, 2001.33, going towards 2001.2. 2122. And if you look inside the packet, this is being seen as the ICMPv6 type ping. Okay, you can see as it exits R1 right here, the IP gets translated both for source and destination once across the V6 to V4 network. So the source becomes 3.3033, and the destination becomes 172.16.02, which is the R2 loopback 0 native IP. Okay, and the ICMP itself becomes a version 4 ICMP as well with type 8, which is ping request. All right, and then the return packet, which is ICMP echo reply, as it crossed over from V4 to V6 boundary, the IP gets untranslated back to 2001.22 to 2001.33. Okay, let's go back to R3 and complete our test. So far we ping the 2001.22. This time it's trying to ping 2001.21, which is our DNS server. I can see that's pingable. Next, let's try to do a telnet to 2001.22, sourcing from loopback 1, and that would be, again, R2 loopback 0 interface. Here we have the password not set, so let's jump onto R2 and do a quick line VTY 04, password Cisco, and then lock in. And let's try that again. You can see we get dropped into the password prompt, Cisco, and here we're in the R2. Okay, while we have that telnet session up, let's hop to R1. You can see some of these debug output from the source 2001.33 gets translated to 33033, and for destination 2001.22 is translated to 172.16.02. And if we do show IPv6 NAT translation, you can see that since we did the telnet twice, we have two entries here. So if you look at, they're pretty much similar except from the source port that's been changed. But you can see with the IPv6 source 2001.33 and the source become 33033, and then 2001.22 becomes 172.16.02. And you can see how the router maintained the state or NAT state of each TCP session in its NAT table. And since we did the static 1-to-1 NAT, the NAT should be bidirectional by default. So if we're on R2 and we're trying to ping back to 33033, sourcing from its loopback 0, you can see that's pingable. So R2 can also reach inside to R3 as well. And if you get onto, let me exit out of that. These are the debug on R3. And you can see the source was coming from 2001.22, which is R2 loopback 0. With the destination of 2001.33. So obviously the NAT translation allows bidirectional traffic initiation. So let's go back to our task list and make sure we have met all the requirement for the static NAT, and I believe that we did. Next we need to configure Dynamic Nat on R1 to allow R3 loopback 2 to communicate with R2 loopback 1 so that any IP from 2001.301/64, which is the subnet of R3 loopback 2 interface, appears as one of the IP between 3311 to 32. And this is primarily to reserve the IPv4 addresses. So you can see if we keep doing a static 1-to-1 NAT from V6 to V4, and since V6 has such a larger IP space, you will eventually run out of IPv4 space. And also the task requires us to use the access list as part of the NAT command as well. So this is what we're going to be configuring as far as the source translation using Nat Pool. So to do that on R1, we first have to create a NAT pool. So the command is IPv6 NAT, and if the question mark, we do v6 v4 and then pool. And we have to give it a pool name. So let's call it NAT v4. And then the start IP is 3311 as specified in our task. And the end IP is 33132. And the prefix length is 24. And then we need to create a access list to match interesting traffic. So let's call it R3 loopback 2 and permit the subnet of R3 loopback 2 is 2001.301/64, and the destination we're just going to put any. And now this is similar to when you're configuring a dynamic NAT on IPv4. As far as the syntax, so the syntax is IPv6 NAT v6 v4 source list, since we're using access list as required by our task, And our matching access list is call R3_LO2, matching to the pool of NAT-V4 that we have, and then enter. Okay, so now if we go to R3 and perform another ping to 2001.22, this time sourcing from loopback 2. For some reason it didn't go through, so let's see if we still have the debug turned on. So show debug. So let's do, actually we do NAT-PT. That means it probably didn't match our access list, so let's do show access list. Actually it did match. So let's see why maybe there's a typo on the command. So let's see. Let's do this. No of that, and then do IPv6 NAT, v6 v4, and source list. And just make sure that I did not have any typo in the name. So let me scroll up for the list right here, copy paste, and then pool. And let me copy the pool as well right here, enter, and let's try that again. Okay, so you can see we have successful ping. I think we might have a case different right here with the lowercase v here. That should have been uppercase. I think that's what the problem was. Okay, so you can see now that we have successful ping. If we hop on to R2, you see that R2 is seeing the traffic is coming from 3311, which is the first IP address of our NAT pool. And you can see that from the NAT debug on R1 as well, with the source of 2001.3013. being translated to 3311, and then the destination 2001.22 to 172.16.02, which is what we configured previously. Okay, same thing, let's try to do telnet. So got the password prompt, and hop onto R1, pretty much the same debug output. I need to do show IPv6 NAT translation, and here we have the NAT entry, and again it maintained the state all the way to the TCP of the protocol and the port of the translation, just like how we had the one-to-one NAT. Okay, so that's for the dynamic NAT. The next part of this task is to configure PAT or port address translation on R1 to allow R3 loopback 3 to communicate with R2 loopback 1, so that any IP from 2001.302/64 appears as 3323 to R2. And again, this is to reserve the IP even more, since most of the IPv6 addresses will be padded to just a single IPv4 address. And obviously the traffic can only be initiated from the v6 side, since it's a PAT, just like how you have the v4 PAT. And the task also requires us to use route map as part of the NAT command. Okay, to configure a PAT, unless we are padding to an outside interface, which we do not in this task, we're going to have to create a pool, a NAT pool. So IPv6 NAT v6 v4 pool, just like how we did earlier with Dynamic Nat. Instead of creating a range of IPs, it's just going to be a specific IPs. Since for us we just need to path to a single IP, which is 3323, prefix 24. But obviously if you want to do path, this can be multiple IPs. The difference is when you do the NAT command, you'll see in this seg we have to put overload at the end. So now we need to do an IPv6 access list. R3, let's call it R3 loopback 3, with the matching statement of permit 2001.302/64 to any. And then since we're not allowed to use access list, but instead we need a route map, so we create a route map. Let's do a matching name, LO3 permit 10, and then we'll match IPv6 address 3 LO3, and then we tie that to a NAT statement of IPv6 NAT v6 v4 in source. Instead of list, we use route map, and let me copy and paste the route map with the pool of PAT v4. And then right here, the difference between Dynamic Nat and the PAT is just the overload option in the end. So we do overload, enter. And now if we go back to R3 and trying to ping 2001.22, sourcing loopback 3, you got successful ping. And if you look at the R2, it's now seeing the IPs coming from 3323, which is our padded address. And also if you look at the translation or NAT, the debug NAT, We got the source translated to 3323. The destination translation stays the same. Okay, let's also try the telnet just like we did earlier. Okay, now sourcing from loopback 3, and then we'll show IPv6 NAT translation. You can see right here with 2001 3023 gets translated to 3323. That's for ICMP, and the same thing we have here for our telnet session. It maintains both source destination IP and the protocol and the port. And I think when we tested back in the Dynamic Nat just before, I believe we didn't source from the right loopback. So let's try that right now. So let's go back and test the telnet sourcing from loopback 2. I think I didn't realize that I was using an incorrect loopback. I was still using loopback 1 back then. So now that we're using the correct loopback 2, let's take another look at the Dynamic Nat. Just right here, there you go. So 2001 3013 gets translated to 3311, which is coming from the Nat Pool, okay, with the telnet session. Okay, so that's pretty much completes our task number 1.